All right, so where does this go next? Well, the main takeaway was you're now free to use direct substitution when it's available to you in order to evaluate limits. But let's take a look at a function. Let's consider the function, or let's consider the limit as x approaches 2 of the function x squared plus x minus 6 divided by x squared minus 7x plus 10. Well, what my limits say I can do is I can look at the limit of the numerator and I can look at the limit of the denominator and I can evaluate these from direct substitution. So let's take a look at the limit of the numerator as x approaches 2 of x squared plus x minus 6. Well, if I substitute 2 in, which I learned in this lesson, I can evaluate this limit just by plugging 2 in. 2 squared is 4. Plus 2 is 6, minus 6. The limit of the numerator is 0. And that's fine. I can have a 0 in the numerator, so I haven't run into any kind of issue yet. It's when I look at the denominator, and I look at the limit as x approaches 2 of it, x squared minus 7x plus 10. 2 squared is 4, minus 14 is negative, 10 plus 10 is 0. I get a 0 in the denominator as well. And it's a very curious thing whenever I get a 0 in the numerator and a 0 in the denominator. We know this gives us an issue, but something interesting happens actually when we get it in both. So anytime direct substitution takes the form of 0 divided by 0, we call this particular form, 0 divided by 0, the indeterminate form. We call it indeterminate because there's nothing we can actually determine from it yet. The function is undefined at 0 because it gives me 0 in the denominator. But this doesn't tell us anything about the limit. So it does mean f of 2 is undefined. That's a true statement. I can't substitute 2 in. I basically tried here and got 0 over 0. But the limit as x approaches 2 of this particular function, which I'll call f of x here, it does exist. In fact, we'll find it in the next topic, in topic 1.6. We will figure out that this limit exists, and that's what we will evaluate. So we will evaluate it in topic 1.6. And I will tell you that we've looked at functions like this, and we've learned how to evaluate them graphically and tabularly. But what we're also going to look at in this next topic is this idea that whenever I get this form 0 divided by 0, that I can actually evaluate this limit through just a little bit of algebraic manipulation. And if you look at what's happening with this function, you can probably guess which algebraic techniques we're going to apply to the numerator and the denominator, and we're going to watch some beneficial things happen to us. So in your mind, be thinking about what you can do to this function, and we'll cover that in topic 1.6.